This is the masking handbook for audiometry. In this video, we'll be looking at determining the initial masking level, or the IML. We'll take a look how to determine our IMLs for both the plateau and optimized methods of masking. In both of these cases, our test ear will be the right ear, and we'll need to test the bone conduction responses from that ear. The non-test ear will be the ear we want to mask. In both cases, it's the left ear. Let's look at 1000 Hertz for both situations. We have the two methods of masking. Our reference points for determining the IML for the two methods will be different. For the plateau method, the reference is the hearing threshold of 1000 Hertz in the left non-test ear. For the optimized method, the reference is the hearing threshold of the right test ear. Let's start with the plateau method. Here are the three items that we need to consider or quantify to determine our initial masking level. The first two are compensation values, which we need to include in order to provide a foundational level of masking. The third value is the actual masking noise level that provides an active masking effect. Let's use 10 dB as our active masking level. We'll need to determine the values of the other two items. The first item is the hearing threshold of our non-test ear. We need to compensate for this situation. In this case, it's 20 dB. So the first part in constructing our initial masking level is a 20 dB value. We often need to compensate for the occlusion effect during bone conduction measurements. We're using insert earphones, and our test signal is 1000 Hertz, so the occlusion effect compensation here will be 5 dB. We'll include that level into our IML construction. Now we'll add the active masking level into the situation. As mentioned previously, that's 10 dB. We now have our IML determined for the plateau method, which is 35 dB of narrowband noise. We can now begin masked threshold testing. We'd then establish our first masked threshold of bone conduction from the right ear. After that was measured, we'd move on to the plateauing part of the process. Let's look at the second example. In this case, because the hearing between the two ears is so asymmetrical, applying the optimized method of masking is appropriate. Let's review how to determine the initial masking level, or IML, with this method. With the optimized method, we use the threshold of the test ear as our reference. To find our IML, we subtract 10 dB from this value. We then deliver this amount of masking noise to the non-test ear. Here is our audiogram for the optimized case. We have masked air conduction hearing thresholds completed from the right ear. We want to complete masked bone conduction testing at 1000 Hertz in the right ear. The left ear is our non-test ear. The air conduction threshold of the right test ear is our reference. We subtract 10 dB from that value and come up with a 60 dB initial masking level result. And this is our IML. We introduce 60 dB immediately into the non-test left ear to begin our masked threshold testing. There's nothing stopping us from using the plateau method in this situation. It's still a valid approach. In this case, would start with a 35 dB initial masking level. You can see the value in the optimized method here, however. Our IML of masking is much higher and will save a lot of time. This is the masking handbook for audiometry. If you liked this video, you'll love the handbook. For more resources on masking and to learn how to purchase the book, check out maskinghandbook.com.